Imagine a world so far from the sun that light itself takes more than 5 hours to reach the surface. Out here, the temperature plunges to minus 230 degrees Celsius, cold enough to freeze a glass of water into rock-solid ice in a single second. Time operates on a completely different scale in this deep freeze. One single orbit around the sun takes 248 Earth years to complete. If you were born there, you wouldn't have even celebrated your first birthday yet. This dark, distant place is the planet Pluto. For decades, it held a position as the undisputed ninth and final planet of our solar system. Today, that title is gone. Scientists removed Pluto from the planetary list, raising a controversial question. How exactly does a world lose its status in the solar system? To understand the removal, we have to look at the discovery. In 1930, a 23-year-old astronomer named Clyde Tombaugh was working at the Lowell Observatory in Arizona. Searching for new worlds back then was agonizing manual labor. Tombaugh would take photographs of the night sky days apart, then rapidly flip between them in a machine. If a single tiny dot shifted against the fixed background stars, he knew he was looking at an object orbiting our sun. Once the discovery was announced to the world, an 11-year-old English girl named Felicia Burney suggested a fitting name. She proposed Pluto, after the Roman god of the underworld, matching a world shrouded in distance and cold darkness. For 76 years, Pluto fit neatly into humanity's understanding of the solar system's edge, until our own advancing technology forced a scientific reckoning. That reckoning arrived in August 2006. Thousands of scientists gathered in Prague for a meeting of the International Astronomical Union, where they held a controversial vote to strip Pluto of its planetary status. The astronomers were reacting to a growing crisis. Better, more powerful telescopes had started piercing the darkness past Neptune, revealing a vast ring of icy debris known as the Kuiper Belt. Inside this belt, scientists were finding objects that were similar in size and composition to Pluto. If Pluto was a planet, then logic dictated these new discoveries had to be planets as well. To prevent textbooks from listing dozens of new planets, the astronomical community drafted a strict 3-rule checklist to define what a planet actually is. Rule number 1: the object must orbit the sun. When astronomers checked Pluto against this new standard, it easily passed the test. Rule number 2 requires the object to have enough mass that its own gravity pulls it into a distinct spherical shape. Pluto is round, so it passed this test without issue. Then came rule number 3. A true planet must have cleared the neighborhood of its orbit, meaning its gravity is dominant enough that no other large debris shares its path. Looking at the solar system, inner planets have clear rings, but Pluto is drowning in thousands of icy rocks sharing its own. Viewed from the side, unlike the other planets' flat rings, Pluto's route is wildly tilted, elliptical, and crosses Neptune's path. Because it failed that 3rd rule, the scientific community issued a verdict. Pluto was reclassified under a newly created category, a dwarf planet. The dwarf classification reflects the reality of Pluto's scale. Placed next to Earth's own moon, the moon is significantly larger in diameter. This demotion was a necessary mathematical categorization of a small object overwhelmed by its environment. Right as astronomers were debating Pluto's status, NASA launched the New Horizons spacecraft. It blasted off at 58,000 kilometers per hour, making it one of the fastest machines ever launched from our planet. Even at that pace, the distance to the outer solar system meant the journey would take 9.5 years to complete. This timing created a historical irony. When New Horizons left Earth, its target was officially the 9th planet. By the time it arrived in July 2015, the world it was visiting had been downgraded. Based on its size and freezing location, scientists assumed they were approaching a dead ball of cratered ice. Instead, the data they beamed back revealed a geologically active world. The close-up images from 2015 revealed a geologically active, complex environment with a surface in constant motion. Dominating the landscape is the Tombaugh Regio, a Texas-sized plain of nitrogen ice shaped like a heart. Bordering this heart are mountains that rise 3 kilometers into the sky, made of solid water ice. Weaving through these jagged mountain peaks, vast glaciers of frozen nitrogen slowly and continuously flow across the icy surface. Pluto maintains a thin atmosphere that essentially breathes, turning into gas when it edges closer to the Sun and snowing back down to the surface as it moves away. A leading theory suggests that radioactive decay inside Pluto's rocky core is generating enough heat to melt ice from below. This points to a subsurface ocean that could potentially support microbial life. Pluto's reclassification stands as a milestone in astronomical precision. It demonstrates that, as our tools evolve, our definitions must keep pace to reflect a cosmos more complex than a simple checklist could capture.